Okay, so here we go. The first pre-calc YouTube video of the year, covering sections 1-1 through 1-5 for your quiz on Tuesday. I have 5 problems. Let's go through these 5 problems that will be somewhat on your quiz. Alright, here we go. First one. Use algebraic test to check for symmetry with respect to both axes and the origin. So let's recall that if we're going to check x-axis symmetry, that means that these points are on the graph. If it's symmetrical about the x-axis, then xy and negative xy are both, and x negative y are both on the graph. So we need to plug in negative y for y and see if we get the same equation out. So x parenthesis negative y squared plus 10 equals 0. We need to square the negative y first, which will make this negative become a positive. And voila. That is the original equation. Yes, this has x-axis symmetry. Okay, what about y-axis symmetry? Well, to test for y-axis symmetry, the point xy and negative xy will be on your graph. So you need to check to see if negative x produces the same y value. So we plug negative x in for x. The y squared remains a y squared. Well, this negative, since it's the first power, stays negative and creates a negative xy squared plus 10. And this is not the original equation, so it does not have y-axis symmetry. The last one we'll check for is origin. And origin symmetry means if the point xy is on your graph, then the point negative x, negative y should also be on the graph. So this time we plug negatives in for both. So the x becomes negative, the y becomes negative. So the first thing we do is we square the y. So this negative x doesn't change. So it stays negative x. And the y squared, the y becomes positive. Positive y squared. So the x stays negative. These two negatives do not cancel. You do the squared first. Y squared, negative y squared becomes positive y squared. The negative x comes down. And this, again, is not the original equation. So it does not have origin symmetry. So this equation only has x-axis symmetry. Typically, equations only have one type of symmetry. Next problem. We're going to find the domain of this function. So there are two issues. Remember, one, divide by 0. So you can't have 0 in the denominator. And 2, you have even roots of negative numbers. So you can't have negatives underneath the square root. Okay? So in this case, we have denominators. And we have x in the denominator. That would be this, division by 0. You can't divide by 0. So your denominators cannot be 0. So x cannot be 0. And x plus 2 cannot be 0. So we're finding the values of x that x can't be. So here we subtract 2 from both sides. And here x cannot be negative 2. So the two values that x cannot be in this function are 0 and negative 2. So how do we write that? Well, we'd like you to use interval notation. So x can be anything else but these two values. So we start from negative infinity, and we go up until it can't be negative 2. And since it can't be negative 2, that's an open, that's a parenthesis. Can't be negative 2. Union with. Now we start with another parenthesis, and we pick back up at negative 2. Again, it cannot be negative 2, so that's why the parenthesis is there. And we go until we get to 0, and we stop. We can't be 0, so we close the parenthesis. We create another union. We open our parenthesis. We pick back up at 0. And we go all the way to infinity, because we could be everything else. And there's the domain, D for domain, of this function. Okay? So remember these two domain issues when doing a problem. Alright. Okay, number 3 here. We are going to do the difference quotient of this function, f of x equals x cubed plus 3x, for this difference quotient. So first, let's evaluate f of x plus h. That would be x plus h cubed plus 3x, or 3 times x plus h. So this first one's nasty, okay? I'm going to do it just right here. X plus h times x plus h times x plus h. 3 terms. Now the first two, let's FOIL, x squared. The outer and inner term are the same, so you get 2 of them, 2xh's, and then the last is h squared. Put that in a parenthesis because it still has to be multiplied with x plus h. And now we have to do the big distributive property. X squared to x becomes x cubed. X squared to h becomes x squared h. And that's the x squared's done. 2xh to x is plus 2x squared h. The x's make x squared. 2xh to h becomes 2xh squared. The 2hx is done, sorry. The 2hx is done. And then h squared times x is xh squared. H squared times h is h cubed. And the h squared is done. And now we're combining the like terms. X cubed is the only x cubed term. We have an x squared h here, and 2x squared h is there. That's 3x squared h. So these are done. We have 2xh squares and one more x h squared. That's 3xh squareds. And then we have an h squared here. So there's f of x plus h. So I'm going to scroll down a little bit. So now in the difference quotient, we put that x cubed plus 3x squared h plus 3xh squared. So we're going back to here, what f of x plus h is, because we still have this part right here to do. See this? I haven't touched this yet. So this is just evaluating x plus h into f. So we have what x plus h cubed is. It's this. And then we need to bring down this guy. And this guy, when we distribute, becomes plus 3x plus 3h. And this is what f of x plus h is, this thing. Okay? So now just to save time, I'm going to scribble this out. This will be the start of my difference quotient, this thing. I'm going to then subtract f of x. F of x is x cubed plus 3x. So when I subtract it, you have to take the opposite of these two terms. So the x cubed becomes a minus x cubed, and the positive 3x becomes a minus 3x. And that's all over, sorry, it's a long line to draw on this tablet. That's all over h. And now we like to see what simplifies. Now, things should cancel. X cubed minus x cubed, gone. 3x minus 3x, gone. Anything without an h should go away. All the h things should stay. 3x squared h plus 3x h squared plus h squared plus 3h all over h. And as I said, anything anything with an h should stay, and the h in the bottom should cancel, and it does. So there's an h here, and there's an h in every other term. So this h goes away. This h squared becomes h to the first, this h squared becomes h to the first, and this h goes away, canceling out the bottom h. And we are left with 3x squared plus 3x plus h plus 3. There we go. So pretty difficult when you get to cubing a binomial, okay? But again, the difference quotient, same way for all the different problems. Okie doke, problem 4. Here we're going to talk about when this function is increasing, decreasing, and constant. Okay, so let's start with increasing. So we're looking for when, left to right, the graph goes up. That's increasing. Well, it looks like it starts going up here to there. That would be from negative infinity to this x value. This point right there is 0, 3. So the x value is 0. So it increases from negative infinity all the way to 0. That's an increase. Okay. Then does it increase anywhere else? Well, yeah, here, look. This is going up. So this point right here, even though it's an open circle, we can still label it as 2, 5, technically, because it's an open circle, it's not on the graph, but I need an x value to start with. Notice we always use parentheses for these because we are never that value at the point where it changes. So this would be from 2, x is 2, to infinity. Alright, decreasing. We're looking for, I'll use a different color, sorry. I'll use decreasing. Now we're looking for when left to right the graph is going down. None. There's no intervals where this is decreasing. And then finally we'll look at constant. And constant is where the graph's going straight across. And here it is right here. Between these 2 points. X values 0 to 2. And there's your intervals of increasing, decreasing, and constant. Okay, last one here. Determine whether the function is even, odd, or neither. And we're not going to talk about symmetry. That's fine. So, if your function is even, now if we do talk about symmetry real fast, even means you have y-axis symmetry. And if you have y-axis symmetry, that means the point xy and negative xy should be on your graph. So we are looking to plug in negative x and still get the original function out. That's the idea. Okay? Now odd is origin symmetry. So for origin symmetry, remember the point xy and negative x, negative y on your graph. So when you plug in negative x into the function, you are looking for negative f of x, or the opposite of the function, to come out, because you want a negative y. Okay? So we're going to plug in negative x into our function and see what happens. Well, g of negative x equals negative x to the third minus 5 times negative x. If we simplify this, negative x cubed stays negative x cubed. Negative 5 times negative x is positive 5x. So that's what we get when we evaluate g for negative x. And let's see our original function. It was positive x cubed minus 5x. Now it's negative x cubed plus 5x. This is the opposite of g of x. Right? Everything changed sign. Therefore, this graph, this function, has is odd, because there is origin symmetry. So this graph, this function, would be odd, and the graph would have symmetry about the origin. Right. So here's 5 questions that I feel we need to get a little extra help on. Hopefully this proved useful, and you will do well on your quiz coming up on Tuesday. Alright, thanks for watching. Have a great day. We'll see you later.